EnergyBus is an open standard for integration of and communication between electric components of light electric vehicles based on DC. It includes standards for both a communications and power distribution bus and a corresponding connector system. Data transmission is based on a CAN bus, specifically CANopen. EnergyBus is standardized through CAN automation in CIA 454. The EnergyBus specification is published through the EnergyBus Association, based in Germany. Members are individuals, as well as manufacturers of components, vehicles, systems, and retailers. Members are from all over the world, and include Bosch, Panasonic, Sanyo, Deutsche Bahn, Philips, and VARTA. One major goal of the EnergyBus effort is compatibility of charging equipment with different battery types and chemistries for e-bikes, pedelecs and other light electric vehicles. Layers. The EnergyBus standard is defined on several layers. The physical layer consists of the plug and socket used to connect separate components. The EnergyBus connector contains 6 contacts. 2 contacts are for DC power up to 1.5 kilowatts. 2 wires carry auxiliary DC power to drive non-power components, such as energy management systems and sensors. Finally, 2 wires carry the CAN data bus high and low lines. Currently, EnergyBus power lines support DC voltages between 12 and 48 volts DC. The current is currently limited to 30 A, for a capacity of up to 1.5 kilowatts. An extension up to 60 A is in the works. Also 300 A is under draft. The information bus layer ensures components of the electric drive and security system of a vehicle or charging island system work properly together, even if they are put together without planning. The information bus definitions define messages and how they are exchanged for specific use cases. The attributes of each message, and values inside the message itself, are defined. All definitions are specified for more than 10 different types of components. Benefits to the system user, e.g., the owner of an e-bike or the user of an electric power island system. One charger can be used for batteries of different producers and chemistries. This ensures safe and secure charging under conditions of changing batteries. This also allows batteries to be upgraded through the years while keeping the power adapters. Plug-play electric energy island systems based on DC power can be built, so that the addition of batteries after the initial design at 12 volts to 48 volts DC is possible without security risks. Benefits for component producers. Vehicle designers and electric systems architects may easily add new components without specific electronic design needs. Such components therefore have an advantage in comparison with less intelligent components. Benefits for system integrators. EnergyBus adds speed and flexibility at the system design phase. The design can be built on ready-made definitions and therefore needs less work on defining such. EnergyBus components may be put together with reduced complexity. The offered system is upgradable to new battery chemistry or parallel batteries, for example, without changes in the software. Applications. Components. A full range of e-bike components is available as of 2012, including electric motors by Acron, 300-watt power conversion adapters by Panasonic Industries with Electrogel software, bike lights by Philips, several designed batteries by High-Tech Energy, and human interfaces by Marquardt. For island systems, a specific inverter was developed by CACO. Electrogel, a Swiss company located close to Winterthur, markets an integrated e-bike component system. Peronex, a German company, located at the Baltic Sea, provides a large scale of EnergyBus products like intelligent charger, battery adapters and input-output devices. MobiPus, a Taiwan company, located at New Taipei City, provides complete line of PMSM motor controller, from 48V to 300V, for electric motorcycle and scooter and battery management system. EnergyBus component developers can make use of a set of pre-packaged software libraries and a framework of development tools. E-bikes. The Impulse, the first e-bike based on EnergyBus, was introduced by Tordswiss, TDS, in Switzerland in 2012. Not to be confused with the e-bike Impulse available in Europe by a different brand. The Impulse is built on the Electrical system. The Gobix G1 is a e-bike for heavy goods transport introduced in 2012 by Gobix. Infrastructure. Public charge stations for pedelecs have been deployed in the Tegernsee region. Island power systems. There are numerous applications in stationary systems. Examples are repeater stations in mobile communication networks, measurement stations, off-grid housing, village DC grids, and off-grid water pump stations. The Fraunhofer ICE is using EnergyBus in electrical island systems in Egypt with PV and batteries, including the CACO converters. Other applications in discussion are motorhome equipment, boating and bike port systems. Outside view. EnergyBus is young. Therefore, not all the expected definitions are finished. Members are expected to help in finishing the definitions and documentation. This situation is not valued by everybody. State of the standard. General adoptability was reached with version 1.0, released in late 2011, for both power adapter and battery. The major accomplishment in this version was the physical definition of plug and socket, as well as the interworking of the power adapter with the battery. Future. There is broad activity and progress on the standard. The version 2.0 of the standard with general definitions and a full scope of component descriptions is expected to be released in 2014. An international ISO/IEC standard will be published end of 2014. Additional activity is underway to develop a charge lock cable. History. Discussion of what today is EnergyBus started around the year 2000. Centered on the topic of serial hybrid light electric vehicles like Extra Energy and Andreas Fuchs. Those ideas went through many iterations. There are patents pending. The organization. The EnergyBus organization is set up as a German association. The driving people behind the organization are Andreas Fuchs, Mo Hua-Yang and Hannes Neupit. EnergyBus works with partner organizations. For example, CIA is organizing the standardization work. OPI 2020 is working on international standardization. And EnergyBus GmbH is set to provide compatibility testing end of 2014. Memberships. Members support the standard and receive information about the standard. 3 levels of membership are currently available. Associate membership. Associate members support the standardization process through actively developing the various standard definitions. Associate members have access to the respective documents in draft versions. Adopter membership. This membership is for implementing partners that wish to work only with the finished documents. E.g. version 1.0. Community membership. This membership is currently in trial, beginning with partners from educational institutions. Community members receive access to documentation, and in return provide open source or open hardware licensed results published on publicly accessible versioning systems like GitHub or Google Code.